In today's lesson, we're going to talk more about probability, specifically theoretical probability and what's called experimental probability. So probability is a way of measuring the likelihood of a particular outcome. The way that we represent this probability is using a p and then parentheses around the event that we're talking about, and then define the number for the probability. We do the number of favorable outcomes, and we divide it by the number of total possible outcomes. And so that, when we do that division, we're going to end up with a number from 0 up to 1. So it'll be somewhere on the interval from 0 to 1. Where the number could be any real number between or including 0 and 1. So for this first example, the song list has 9 dance songs and 6 slow songs. What's the probability that a randomly selected song will be a slow one? So for this, we would call this P, just call this P of slow, the probability of a slow song. And so the number of favorable outcomes would be 6 for slow songs, and then total would be the total number of songs, which would be 9 plus 6, or 15. 6 divided by 15 is 0.4, and that number falls between 0 and 1. And so there are going to be 3 different ways that you might see probabilities written. One of them would be the decimal form, which we see here. Another would be the fraction form. Now, the simplest form of 6/15 is 2/5. And the third way that we might see is the percentage. And 2/5 is 40%. So we've got these 3 ways. In general, putting the fraction in simplest form is a good way to do it, unless you can find an exact decimal. And so if you can find an exact decimal, then that's probably preferable. But if you can't, then just leaving in fraction form is fine. In this next example, we've got rolling dice. 2 dice are rolled, and we want to know the probability of having a sum of 10. So we need to find the number of favorable outcomes and divide it by the number of total possible outcomes. So to find the number of total possible outcomes, we can look and see that we'll call this one die 1 and the other one die 2. Die 1 has 6 possibilities and die 2 has 6 possibilities. So all of those combinations will make 36 total possible outcomes. So probability of sum of 10 is going to be something divided by 36. Then we need to find how many times will you get a favorable outcome if we list all of the possible combinations. So let's take a look. If you roll a 1 and a 1, that sum will be 2. A 1 and a 2, a sum will be 3, and so forth. So you can fill in this table. Oops, not that. We can fill in this table, and that's going to give us all of the possible sums. And you can see already that some of these sums appear more frequently than others. As you can see, 2 can only happen in one circumstance, and that's by rolling a 1 on both dice. Some of these others are possible in more than one case, and you can see that 7 is possible most frequently. All right, so completing this table, we can see that a sum of 10 is possible in 3 scenarios. These 3 right here. And so we've got a 3 out of 36 probability, which if we simplify that fraction, we've got 1/12. That would be approximately, as a decimal, 0.083 or 8.3%. But if we need to give an exact answer, which is usually what we need to do, unless we're told otherwise, then we'll give 1/12. Probability of a sum being 7. I'm just going to use S7 for sum of 7. That probability would be, whoops, undo that. Out of 36 possible outcomes, a 7 sum will occur 1, 2, 3, 4, 5, 6 of those times, which would be 1/6. Or if we change that into a decimal, that'd be approximately 0.167 or 16.7%. So we can see it's twice as likely that we would have a sum of 7 as a sum of 10. Last, a difference of 6. Now if I look at die 1, the biggest obviously that you can have is a 6, and the smallest that you can have on the other die is a 1. Difference between those numbers is 5. So the greatest difference is 5. As a result, it's impossible to have a difference of 6. So that probability would be 0 out of 36, which would be, as a decimal or a percent, 0 or 0%. Now I mentioned earlier that probabilities as decimals can range from 0 to 1. 0 meaning that that situation is impossible, and a 1 meaning that that situation is certain. Halfway in between would be 0.5 or a 50-50 chance, kind of like you would get if you tossed a fair coin. Next up, the probability of an event. If the probability of an event E is described as P of E, then the probability of its complement, spelled with 2 E's, of its complement, which would be anything but E, is the P of not E, and that equals 1 minus the probability of E. Now we're going to put that into practice in this example about the game of Battleship. So with Battleship, we've got 5 ships and we have a 100-hole grid. So using the chart below, calculate the probabilities of guessing on your first guess and hitting the destroyer. So we know that the destroyer has 2 holes on it, and there's 100 holes that you could guess. So that probability is going to be 1/50th, or 0.02, so very unlikely, 2% probability. Next one is the submarine or a battleship. So the submarine has 3 holes and the battleship has 4. So adding those together, you've got 7 out of 100 on your first guess, meaning you've got 0.07 or 7%. Last, the probability of a miss. So a miss is essentially the complement of a hit. It's anything besides a hit. So we can find the probability of a hit and do 1 minus that, and that would give us the probability of a miss. I think I might have misspoke there. Let me repeat myself. We can do 1 minus the probability of a hit, and that will give us the probability of a miss. So the probability of a hit is going to be, out of 100, 2 plus 3 plus 3 plus 4 plus 5. So that would get us 5, 8, 12, 17. And so 1 minus 17 over 100, just change that to 100 over 100. Probability of a miss is 83 out of 100, or 83%, so it's quite likely that on your first guess on battleship that you'll miss. It's about 5 out of 6 if you did an approximate smaller fraction or simpler fraction. Alright, next one. James gets his 4-digit library code to use at the library computer, and no digit in these library codes repeat. So James gets his code, and his code is 7654, and he finds that kind of interesting because those are consecutive digits. And he's wondering, what's the probability that he would get a code like that? One which has all 4 digits consecutive. Now these could be consecutive going up or consecutive going down, as is the case with James. So, we need to decide first off, is this situation a permutation or combination? Now, since order matters, this must be a permutation. Then, the next step that we would do is we need to find the total number of outcomes of 4-digit codes out of these 10 digits. So, we've got 4 spots. 1, 2, 3, 4. Now the first one could have 10 digits. And the next one, now the next spot, remember that no digit repeats. Next spot would have 9. Next would have 8. And the next would have 7. So if we multiply that out, I'm going to pause the video so I can go grab a calculator so I can multiply that out. And I'm back. So multiply that out and we get 5,040. If you use the formula for permutations, use the formula for 10 for, come on, like that. And then you would use 10 factorial over 10 minus 4 factorial, and you get the same result. Next, for probability, we need to find the number of favorable outcomes so we can divide it by our total number of outcomes that we just figured out. So the number of favorable outcomes would be, well, let's list them out. 0, 1, 2, 3, 1, 2, 3, 4. We've got 2, 3, 4, 5, 3, 4, 5, 6, 4, 5, 6, 7, 5, 6, 7, 8, 6, 7, 8, 9. And that's the last one for ascending numbers. Descending then, we would have 9876, 8765, 7654, 6543, 5432, and then 4321 and 3210. So we count each of the ones we've listed here twice, because you could be going up with them or down with them. So we'll have 2, 4, 6, 8, 10, 12, 14. So that probability of consecutive numbers is going to be 14 out of the 5,040 total. Simplify that fraction. We would have 7 out of 2,520. Now if we need to get an approximate number, then we can divide that out, and we would have approximately 0.002, and then I believe the 7s are repeating there, going on, or approximately 0.28%. So about 1/4% is the probability that James would get a code like the one that he had. So far we've done theoretical probability, and in next video, part 2, we're going to do experimental probability, which is sort of probability that comes from data from experiments.